Hi, students.
Okay, so today you are going to do a lab activity, a launch lab, and it's on page 83 if you want to read through it, but here's what it says. I'll read through it for you. It says, how can objects be organized? So what would it be like to shop at a grocery store where all the products are mixed up on the shelves? Maybe cereal is next to the dish soap and bread is next to the canned tomatoes. It would take a long time to find the groceries that you needed. So how does organizing objects help you find and use what you need? So then it says to take blocks, different blocks, and I do have a picture that I'm posting into Google Classroom of the arrangement of blocks that I have. I took a shot from above. And it says, think of ways you might group and sequence the bricks so that they are organized. So that you would know, okay, so I need green with 2, or small green with 2, large green with 2. So it's like doing your shopping, okay? So how would you organize these? So that was the first thing I wanted you to do back there, is with a small group, take a couple minutes and decide how you're going to organize them. Are you going to organize them solely by color? Are you going to, so that means we have a couple different shades of blue, got all this yellow going on. Are you going to do solely by color and put them on the grocery shelf just by their colors? Or do you want it to even be more organized? Do you want it to be by size? So I could do, that's a 1, that's a 2, that's a 4. I couldn't find any more of these guys. The grandkids must have had some fun with them and put them somewhere. Then I could do this blue, could be small ones like that, okay? Then, you know what I like? I'm looking at this going, you know what? Okay, color is important by color, because that would tell me something specific if I need that color, right? What if I wanted all the little ones regardless of color? So maybe then I can create like this one has a weird like flow to it, right? Yep, that's a different 4, but it's 4. Oh, this guy doesn't have a whole lot in his path, does he? All right, let's see what we got with, oh, this is reminding me of what Mendeleev did. Really and truly is. See, Mendeleev, Dmitri Mendeleev, he was Russian. Sounds Russian, right? He was Russian, and he had put all the information that they knew about the elements on like cards, like just a card, and he had the information in the same order on each card. And so he started trying to organize the cards. Oops. And within organizing the cards, he could see certain patterns that were happening. Do you kind of see I have some gaps with some of the colors? Well, that's what he noticed. Mendeleev noticed that there were gaps in the cards. There were things that were missing, that it seemed like there was a pattern and then it stopped and then it picked up again. Or there was a pattern, and that would be a vertical pattern. There were also, or that would be a horizontal, excuse me. That would be a horizontal pattern. But then he also thought, well, there's some vertical patterns going on as well. See, we have, every color has a single one. So it's like, But then this one is missing a 2. This one's missing a 2, but all the rest of them have a 2, so there seems to be a gap here. So that's what Mendeleev did. He had all the elements on cards, and he found gaps. And he predicted that at some point we would discover, not invent, remember there's a difference, we would discover that element where that gap was, or these elements where this gap is. There's a big gap here. There's probably a couple elements here. So that's Dmitri Mendeleev was credited with coming up with the first periodic table of the elements. So what is the periodic table? It's the organization of the elements. It's based on their physical and chemical properties. But when you base it on their physical and chemical properties, you find out that the pattern goes from atomic number increasing by 1. Now, when Mendeleev did it, he did it solely by mass. He didn't do it by atomic number, he did it by increasing mass when he was organizing it and saw the pattern. So that's kind of like what I was doing. This is kind of like mass, if you will. These are little with 1 prong, 2 prong, 3 prong, 4. Bigger with 1 prong, 2 prong. Gap, 3 prong, 4. As they get more massive, okay? So, and that worked at first. It seemed to work really well. But then there was some noticeable, like, well, wait a minute. Those properties kind of like jump and then come back. There's like a movement of the physical and chemical properties. It's not adding up. Because when you go for the vertical, you could see that they all behaved a certain way. And I've alluded to that when I talked about period 1, all of them are highly reactive. You drop them in water and they go crazy. And there are videos out there if you want to see alkali earth metals reacting with water. There's some good there's some good YouTube videos out there that are fun to watch because they get crazy. They like explode, seriously, just because they touch water. They're so highly reactive. Hydrogen, that's why hydrogen's over there too. It's about the valence electrons. We'll hit that harder later when we have a better idea. So Dmitri Mendeleev, sorted the cards by mass, noticed there were patterns in the physical and chemical properties, and created the first organized periodic table of the elements. Someone by the last name of Moseley came along later and said, you know what, if we can fix these jumps in the pattern of the physical and chemical properties, we can fix that if we go by increasing atomic number. And so when he made that correction in just a couple areas, boom, everything fell into place. And they started predicting the gaps. Okay, there's going to be an element. We will discover an element that fits here. We will discover an element that fits right here. There will be at some point a discovery that finds the element that fits right here. Okay, so that is the periodic table and how it was originally organized and how the system of trying to come up with a way to organize it was constantly being tweaked. Don't think that Dmitri Mendeleev was the only one trying to figure out how to organize them. There were others. He just happened to be the one that did it and published it and got credit for it. All right. And then Moseley was the one that went in, Henry Moseley was that went in and realized that if you made that one little change, that everything would fall into place correctly. So there's some other patterns as you go through your reading. You're going to need to read Lesson 1, Chapter 3, Lesson 1, pages 83 to 88. It's not a heavy read, honestly. I will also give you a guided reading if you want to use it to fill in the blanks. I guess what I need to see that you do it. So if you do the guided reading, just send it back to me so I can see that you completed it. If you do your own notes, that's fine. Take a picture and submit it back to me so that I see that you did it. I'm gonna be looking for some key things. I wanna know that you took some notes about Mendeleev and Moseley, and I wanna see that you talk about how how the periodic table is organized and what's on each box of the element key. You're going to be responsible to know that. There will be a quiz at one point about what's in each box. What does the box tell you? So I'll tell you what the box tells you. It tells you the element name. It tells you the atomic number. It tells you the average atomic mass. It tells you the element symbol. It tells you the state of matter at room temperature. And it tells you which classification. Is it going to be a metal, a non-metal, or a metalloid? So what type of element it is. All that information that you need to take notes on is on 86 and 87. The rest of that whole thing is the periodic table, you guys. So there's not a whole lot of reading, okay? You also need to have notes about groups are the vertical system, like this is a group here. They all have one. They're all very reactive, those ones. They're all highly reactive. Those are groups. They act like a family. They have certain chemical and physical properties that are very specific to that group. Okay? And that's why you would know, okay, this is what I need. I'm going to make an alloy and I need it to be this. I would go to that group and see what in that group I would want to create that alloy with in the metals, okay? Periods are repeated patterns that go horizontally. So they move across. So let me even do this. Groups are vertical. They're also referred to as family. So these are the groups. There are 18 groups. And then periods, there are 7 periods. Periods go vertical. Gosh dang it, I keep saying that. Go horizontal. Periods go horizontal. Periods go horizontal. Ignore my previous. Periods go horizontal. Groups go vertical. Okay? And there are 7 periods, 18 groups. Okay? All right.